Have a pleasant day. Today our topic is kinematics of machinery. Before entering into the kinematics of machinery, we should learn the entire things of theory of machines, which comes under our branch of science, which deals with the study of relative motion between the various parts of machine and forces which act on them. It have categorized into statics. It's a branch of theory of machine, deals with force and their effects. While the machine parts are at rest, the mass of parts is assumed to be negligible. Second is dynamics. It's a branch of theory of machine, deals with forces and their effects while acting upon the machine parts in motion. Then kinematics. It's a branch of theory of machine, deals with the relative motion between various parts of the machine. Then kinetics. It's also a branch of theory of machine, deals with inertia forces which arise from the combined effect of mass and motion of machine parts. Then in our kinematics of machinery, we start with the topic mechanism. Mechanism. So what is mechanism? It is a combination of number of bodies, usually we call it as rigid bodies, are assembled in such a way that motion of one causes constrained and predictable motion to the others. It transmits and modifies the motion. That is mechanism. Then completion of mechanism, we further into the machine. Machine is a mechanism or combination of mechanism importing definite motions to the parts. Also, it transmits and modifies the available mechanical energy into desired or useful work. Then the basic terms we are used in kinematics of machinery is link. So link is it specifies each part of the machine which moves relative to some other part is known as simply link or element, or we call it as kinematic link. So here shown binary link, we have two nodes, so we call it as binary link. And ternary link, it have three nodes. Then quaternary link, it have four nodes. Four nodes means four endpoints. Then characteristics of the link, it possesses two nodes. If we specify link means it should have two nodes. It is a resistant body. Then it have relative motion. Then we can categorize the link. First one, rigid link. A rigid link is one which does not undergo any deformation while transmitting motion. That is a rigid link. And second one, flexible link. A flexible link is one which is partly deformed in a manner not to affect the transmission of motion. Then third one, fluid link, is one which the motion is transmitted through the fluid by pressure or compression. Then structure. It is an assemblage of number of resistant bodies known as members, having no relative motion between them and meant for carrying loads having straining action. A railway bridge, a roof truss, machine frames, etc. are the example of a structure. It differs from machine. This is a structure for example of then common roof truss. It's a bearing point, bottom chord, then truss web, king post, metal gussets. So these are the things in our structure. So difference between machine and structure. The part of a machine move relative to one another, whereas the member of a structure don't move relative to one another. So this is the difference between a machine and a structure. A machine transforms the energy into some useful work. Where a structure, no energy is transformed into useful work. The link of a machine may transmit both power and motion, while the members of a structure transmit force only. Kinematic pair. The two links or elements of a machine, when in contact with each other, are said to form a pair if the relative motion between them is completely or successfully constrained, that is, in a definite direction. The pair is known as kinematic pair. So this is the example for kinematic for slider crank mechanism. Then types of constrained motions. So completely constrained motion. When the motion between the pair is limited to a definite direction irrespective of the direction of force applied, then the motion is said to be completely constrained motion. For example, the piston and cylinder in a steam engine form a pair, and the motion of piston is limited to a definite direction. That is, it will only reciprocate relative to cylinder irrespective of the direction of the motion of crank. The motion of square bar in a square hole and the collar. Incompletely constrained motion. When the motion between a pair can take place in more than one direction, then the motion is called an incompletely constrained motion. The change in the direction of impressed force may alter the direction of relative motion between the pair. A circular bar or shaft in a circular hole, as shown in, is an example of incompletely constrained motion, as it may either rotate or slide in a hole. These both motion have no relationship with the other. This is the example and diagram shown for the incompletely constrained motion. A successfully constrained motion. When the motion between the elements forming a pair is such that the constrained motion is not completed by itself, but by some other means, then the motion is said to be successfully constrained motion. Consider a shaft in a footstep bearing as shown. The shaft may rotate in bearing or it may move upwards. This is a case of incompletely constrained motion, but if the load is placed on the shaft to prevent axially upward movement of the shaft, then the motion of a pair is said to be successfully constrained motion. The motion of an IC engine, valve and piston reciprocating inside an engine are examples of successfully constrained motion. The classification. According to type of relative motion between the elements, according to type of contact between the elements, according to the type of closures we utilized. The relative motion between the elements. First one, sliding pair. When the two elements of a pair are connected in such a way that one can only slide relative to other, the pair is known as sliding pair. So example is piston and cylinder. Type of relative motion between the elements. So second one is a turning pair. When the two elements of a pair are connected in such a way that one can only turn or revolve about the fixed axis of another link, the pair is known as turning pair. Cycle wheels turning over their axles. Cycle wheels turning over their axles. This is an example for turning pair. Then third one, rolling pair. When the two elements of pair are connected in such a way that one rolls over another fixed link, the pair is known as rolling pair. Ball and roller bearing is an example for rolling pair. Then next one is screw pair. When the two elements of a pair are connected in such a way that one element can turn about the other by screw threads, the pair is known as screw pair. Bolt with nut. This is an example for a screw pair. The relative motion between the elements. Next one is spherical pair. When the two elements of a pair are connected in such a way that one element with a spherical shape turns or swirls about the other fixed element, the pair formed is called spherical pair. The ball and socket joint is an example for spherical pair. Then lower pair. So type of contact between the elements. So next one is the lower pair. When the two elements of a pair have a surface contact, when relative motion takes place and the surface of one element slides over the surface of other, the pair is formed is known as lower pair. It will be seen that sliding pairs, turning pairs and screw pairs from lower pairs. A nut turning on a screw, shaft rotating in a bearing, all pairs of slider crank mechanism. Universal joints are example for this lower pair. So type of contact between the elements. Second one is a higher pair. When the two elements of pair have a line or point contact, when relative motion takes place and the motion between the two elements is partly turning and partly sliding, then the part is known as higher pair. Example: wheel rolling on a surface, cam and follower pair, tooth gears, ball and roller bearing. Type of closure between the elements. First one, self-closed pair. When the two elements of a pair are connected together mechanically in a such a way that only required kind of relative motion occurs, it is then known as self-closed pair. Lower pairs are self-closed. Then next one, force-closed. When the two elements of a pair are not connected mechanically but in contact by means of external forces, the pair is said to be forced closed pair. Then kinematic chain. When the kinematic pairs are coupled in a such a way that the last link is joined to the first link to transmit definition motion, a completely or successfully constrained motion, it is called kinematic chain. For example, the crankshaft of an engine forms a kinetic pair with the bearings which are fixed in a pair. The connecting rod with the crank forms a second kinematic pair. The piston with the connecting rod forms a third pair, and the piston with the cylinder forms a fourth pair. The total combination of these links is a kinematic chain. The type of joints in a chain. First one, binary joint. It have two ends only joint. Then ternary joint. It have three nodes combined together. We make the triangle shape like that. So quaternary joint. It have four nodes to join that structure. Then mechanism. When one of the links of a kinematic chain is fixed, the chain is known as mechanism. Classification based on number of links. Simple mechanism with 4 links is known as simple mechanism. The mechanism with more than 4 links known as compound mechanism. Based on mobility. First one, planar mechanism. When all the links of a mechanism have plane motion, it is called a planar mechanism. All the links in a planar mechanism move in planes parallel to the reference plane. Then spatial mechanism have special geometric characteristics in that all revolute axes are parallel and perpendicular to the plane of motion, and all prism axes lie in the plane of motion. Then degree of freedom or mobility. It is defined as number of input parameters, usually pair variables, which must be independently controlled in order to bring the mechanism into useful engineering purpose. It is possible to determine the number of degrees of freedom of a mechanism directly from the number of links and the number of type of joints which it includes. It's denoted by n. So next, Kachbra criterion. So you have 3 bar mechanism, 4 bar mechanism, 5 bar mechanism, then 6 bar mechanism. So it says that we have the number of degrees of freedom. So we can easily calculate the degrees of freedom with this Kachbra criterion. We use n is equal to 3 into L minus 1 minus 2j minus h, where L specify the number of links, j specify number of joints, h specify the number of higher pairs. Thank you.